Hello there, Steven here. Let's try this. I'll show you two web pages, and I want you to tell me which one of them is written by LLMs. Here we have page A and page B. So which page is written by LLMs? Please focus on the text content, not the markup. Okay, so A is probably written by LLMs according to our tools. B is for sure generated because I generated it using an AI website builder. Look at how easy it is. I just typed in a few lines of prompts, specified some posts, clicked some buttons, and it generated an entire site with blog posts. We see lots of LLM web content on the web now. Because of hallucination and plagiarism, you can call such content unreliable, unethical, and so on. And the best part is, they don't tell you it's generated. And you, as a human, often cannot tell, as this study has shown. So, to study LLM web content, we first need to detect them. Specifically, we focus on content that is significantly LLM generated with minimum human input, which we call LLM dominant. So if you use the LLM to polish something you wrote, it doesn't count. This seems simple because there are many LLM text detectors that work well across a wide range of texts, and we can just start from them. But in practice, we are met with these three challenges. First, although state-of-the-art LLM text detectors seem accurate on balanced benchmarks, that is under a high false positive rate, which means they misclassify a lot of human texts as LLM generated. In the wild, less content is LLM generated, so a high false positive rate really hurts. We can modify the detector to reduce the false positive rate, but then they start to miss many LLM generated content. So in practice, they're not very accurate. Second, LLM text detectors are designed for clean prose, like articles. But web content have diverse genres, like lists of things, functional pages, and boilerplate. If we feed these directly to LLM text detectors, they would perform poorly. Finally, even if we had an LLM web content detector, we don't know how to evaluate it because we don't know how to reliably tell whether a piece of content is LLM dominant. So, how do we address these challenges? We propose the following methods. First, if you can't beat them, ban them. For non-prose web pages that text detectors cannot handle well, we filter them out using heuristics based on how much text is in which HTML tags. For example, if a page has too much text in lists or tables, we exclude it from our study. Second, build your own ground truth. We selected 60 human-dominant sites from well-established companies in the stock index and personal blogs in a blogging community that has no commercial interests. Then, corresponding to each human site, we prompted a chatbot to prompt an AI website builder to generate a similar LLM dominant site. We then filtered these baseline sites pages and ran a state-of-the-art score-based text detector to get a detector score for each page. These detectors use a score threshold to try to separate LLM and human text, which is a vertical line here, because the x-axis is the detector score. Each curve is a website, and the y-axis is the CDF of pages per site. As we can see, you cannot use a vertical line to completely separate human and LLM pages. You could, however, perfectly separate the curves, which are the websites. Therefore, instead of detecting pages, we detect entire sites. Of each website's pages, we sample the deciles of their detector scores, the 10th, 20th percentile, etc. And we use these deciles to train a linear classifier. The linear classifier overcomes the text detector inaccuracies and perfectly classifies the baseline sites. We lose the granularity of pages here, but we gain high accuracy in distinguishing which information source is LLM dominant, which is practically more useful. With these methods, we can now study LLM web content in the wild. To test how much LLM content users may see, we did 2,000 Bing search queries on how to do X and classified sites appearing in the search results. Our method flagged a significant 10% of these sites as LLM dominant. And these LLM sites rank similarly high as human sites, which may cause worse search experience. To understand the historical trend, we sampled 10,000 websites from Common Core archives between 2020 before ChatGPT and mid-2025. For sites crawled entirely before ChatGPT, our method flagged a 1.2% of them as LLM dominant, but they should really be human dominant, so this is the false positive rate. And turns out it is due to non-pros pages getting through our filtering. For sites crawled entirely after ChatGPT, the LLM rate increased to 7.3%, possibly because many new sites popping up are full of LLM content. Going forward, we plan to improve our method and understanding. We're seeking your feedback. We plan to improve our baseline dataset with more sites, learn the page filtering from data to replace heuristics, and we need more extensive evaluation to see how robust our method is. We'd like to better understand LLM sites. Through manual inspection, we try to understand what they are, why they're created, for ad revenue, search engine optimization, or scams, and how they're generated. Finally, we would like to understand the impact of LLM web content on the ecosystem, like search engine and retrieval augmented generation, and how they interact with Google Ads. With that, what do you think? I look forward to your feedback that is human dominant. Thank you.